I will tell you this, these are pretty easy. Oops. Okay, so just some sort of preamble here, some introductory stuff. We've already seen that electrically charged objects are able to exert forces of attraction and repulsion on one another without these objects actually being in contact. What do we call that? Being that ability to, a Jedi thing, a force where there's no touching, no contact. There was a specific phrase they used in one of those introductory handouts that I gave you. Anybody remember? Action at a distance, right? So there's, or force at a distance, right? So electrically charged objects are able to exert forces of attraction and repulsion without these objects actually being in contact, or in other words, action at a distance. And this bothered some of those early scientists, right? So they came up with this idea of a force field to sort of get over that. The notion of electric field is used by science to describe how charged objects are able to exert force on one another from a distance, similar to the idea that the Earth's gravitational field is responsible for exerting an attractive force on objects near the Earth. An electric field is thus defined as, so that's kind of important if you want to jot that just a little bit down, right? A region of influence, it's not going to let me do it, region of influence around a charged object. That's what an electric field is. You don't have to write both those paragraphs down. All you got to write down is that sort of definition there. That will do you. Okay, so all we're going to do now is draw those pictures. I'm looking to see, looks like everyone's ready here. Okay, so it says sketching the appearance of electric field in the following cases. All you've got here, this is part A over here, part B, they're not related. These are like separate ones, okay? I've had kids confused by that over the years. So a single positive charge, what does the electric field look like? How do we measure, how do we determine the direction of electric field? The direction that what do we use? Positive test charge or negative test charge? Positive test charge. So if we bring in a little tiny, itsy bitsy little tiny positive test charge, is it going to be attracted or is it going to be pushed away? Pushed away. Okay? And it doesn't matter where you put that, anywhere on the screen. Well, let me move it around. No, it won't. Anywhere you put that, it's going to be pushed away. So the electric field is simply away. Right? All of the arrows need to be pointing out. That's what you need to draw. That's it. Where is the electric field stronger? Where the arrows are closer together, right? Stronger here. Weaker here. Do those lines go forever? They do. What if the charge was doubled? What would the field look like? Twice as many arrows. Right? So something like that. That's literally it. That's all you got to do. What if you've got a positive and a negative, like this one over here? Again, bring in your positive test charge. It's going to be pushed away from positive and towards negative. So you're going to draw all these lines away from positive and towards negative. Away from positive and towards negative. Does that make sense? That's literally it. Away from positive and towards negative. All the arrows are pointing away from positive and towards negative. And what happens if you get those backwards? Say again? You get the question wrong. What happens if you get every single one backwards? You think it's towards positive and away from negative. Instead of 8 out of 8, you just got 0 out of 8. High stakes. Also, easy marks, right? Okay, don't mess this up. I've seen it before. 0 out of 8. Don't mess it up. Away from positive towards negative. You can do it. You all know that red means stop and green means go. Same idea. Right? Away from positive and towards negative. Okay. What about two positives, like so? Again, these are separate questions. You got a positive and a positive. It's always away, right? Away from positive. Away from positive. Away, away. What happens inside there? It's like this. Okay? So there's actually a region in here where the field is quite weak because there's no lines. Right? That would be a good test question. I don't think I've ever asked that. Show me where on a picture like this where it's strongest and where it's weakest. I should do more of that. Where it's strong. Where is it strong? Where the lines are close together. Like here it would be strong, right? Where is it weak? Where there's hardly any lines at all, like right there. It's not hard. Okay, now what about if you've got like a positive charge, and this is like a plate, like a flat metal plate that's charged. Kind of like in like the Millikan apparatus. These are all, this is positive hitting, and these are all negative here. I know they're kind of tiny there. Okay, so again, it's always from positive to negative, right? Away from positive. Does it matter how many you draw? Not really, because I'm not asking you for the overall strength, but, draw me a few. And then towards negative. What about over here on this side? Is there going to be a field over here? On this side? Yep. Towards negative. Towards. Are these hard? No. They're not. They are not. This is probably one of the easiest questions, not only on the test, but in the whole semester. Okay? Get these right. Usually some kid says, couldn't the whole test be these? No. Be nice. Okay, what about now here we got a positive and a negative plate. What would that be like? Away from positive. Away, and then here it's towards negative. Towards negative. Now, the red is the positive field. Does the negative one on the left, does it have its own field as well? It does, so I'm going to draw that in another color. I'm going to draw that in blue, right? Towards. Oh, and what happens in here? So the overall field is strongest where? In the middle, where there's both blue and red, right? There's more field lines in the middle. They're much, much closer together than it is sort of on the outside here. Okay? It's because small objects seem to line up along certain lines that electric fields are often described by drawing electric lines of force, as we've done above. This is a classic example. Let's think way back to like those first couple weeks. This is a scientific model, a physical way of describing something that we can't really see. Trying to bring it all back full circle to that first month. That's it. That's all I got. That's six slides. That's it. There's just a little sort of little practice exercise. This is not the pre-test. Mr. Rich guy. Man, you were supposed to come like before you get today. You weren't going to do it down there anyway. I'll get you in a bit there, Karen. Okay, so all you do on the front, this is like the oldest worksheet I have in my possession. All you do here is a matching thing. So like across that top row, you see there's the number 1 and there's the number 2. Okay, and then way over on the right it says 1 and 2 and there's like a blank over there. So beside number 1, you write either A or B. And then beside 3 or 4, you write A or B. And beside 5 and 6, you write A and B. Okay? It's pretty simple, right? On the back side, you're going to actually draw. Okay, take a few minutes to do that. I'm going to handle pretest number 2, and that is all I have for today. That's the problem. No, that's not true. Hey. Okay, so just the matching one, right? So number 1, that is 1 is like charges. 1 is A, is it not? Oh, I'm looking at the number. Why am I looking at number 2 and saying 1? Yes, 1 is unlike. 1 is B, right? Apparently I can't do it without an answer. 1 is B, 2 is A. Now, can you tell from the pictures on the left there whether they're positive or negatives? What I mean is, like, number 1 has drawn 2 unlike charges, but you can't tell which one is positive, which one's negative. How come? Because there's no arrows, right? There's no arrows, so you can't tell. All right, so 3, that would be which one? That would be unlike. So 3 would be B, am I right? So that'd be B and A. All right. 5 and 6. Now, what do you notice about inside number 5? There's nothing there. So that must mean that they are like charges. So 5 must be A and 6 would be B. 7. Oh, those are kind of different. We haven't seen those kind of things before, right? What do you guys say for number 7? B? Yeah, because they're connected, right? So 7 is B, 8 is A. And then same thing down to 9 and 10. 9 is disconnected, 10 is connected. So 9 must be unlike. No, 9 must be like, right? So 9 would be A and 10 would be B, all right? Okay. Did you get this far? Do you need still a little bit of time? I'm going to wander around and see. I see most people are done. Or 2/3. I'll give you a few more minutes on that back side, and then I'll do those. In the meantime, you guys can start those other pre-tests. If you don't think you're ready for the pre-test, that's fine. You can practice. You've got the rest of this period. Your test is scheduled for Tuesday. Tuesday. Right? And when is the exam? Exam is the last one that I've got. Wednesday afternoon. Wednesday afternoon.
Wednesday after.
You watch me draw them, I guess, right? Okay, so the first two there, okay, you guys got, like, these are easy, right? It's just going to be what? Away, 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 right? Away. Got it, no problem. Positive, negative is going to be away from positive end towards negative. These are so easy. Don't mess these up. These are all positive, so it's going to be away, 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 away. Everything's away. That's how neat it can be. Like, I'm good with that. Okay? Positive and negative. Towards negative. Away from positive. Towards. Yeah? Good?